Hi everyone, I am Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. In the last lecture, we have discussed about the pointers concept. Pointer is nothing but it holds the address of the another variable. And also we have discussed about the advantages of the pointer, void pointer, double pointer, and also a pointer to array. So how we can assign a pointer to the whole array. And now today in this second lecture we are going to discuss about the pointer arithmetic and also about the array of pointers. Pointer to array is different and array of pointers is different. Pointer arithmetic. In this pointer arithmetic we are going to tell about what kind of arithmetic operations we can perform on the pointer variables. As we know, the pointers will store only the addresses of the another variable. So what will happen, what kind of arithmetic, we know the arithmetic operations as plus, minus, multiplication, division and modulus. These are the arithmetic operations. So what kind of arithmetic operations we can perform on the addresses, so that we are going to discuss now. Pointer variables are used to store the address of the variable. Address of the any variable is an unsigned integer, that is, it is a numerical value. So unsigned integer means we can store only the positive values. So we can perform arithmetic operations on pointer values. But when we perform arithmetic operations on pointer values, the result depends on the amount of memory required by the variable which the pointer is pointing. And in C programming language, we can perform the following arithmetic operations on pointer variables. See, coming to the pointer variables and variables. As we discussed, variables we can store the values. Pointer variables we can store the addresses. In values we can perform all the arithmetic operations. But coming to the addresses, we can perform only few arithmetic operations, that is adding an integer to a pointer variable, subtracting an integer to a pointer variable, incrementing a pointer variable, decrementing a pointer variable, subtracting two pointer variables and assigning one pointer variable to the another pointer variable. So these operations we can perform. We cannot perform adding two addresses we cannot add, two addresses we cannot multiply, two addresses we cannot divide, two addresses we cannot find remainder. We cannot perform modulus operation. Only the operations that we can perform for pointer variable is subtracting two pointer variables. So two addresses we can subtract. And coming to this, integer we are adding to a pointer variables, which means for address some kind of integer we are adding. And here integer we can subtract a pointer variables. So any one integer we can subtract from the pointer variables. And also we can increment, we can decrement, we can subtract two pointer variables and we can assign one pointer variable to the another pointer variable. And coming to the addition operation on a pointer variable. And so in the last lecture we have discussed about the arrays of So in the previous lecture we have discussed about the pointer to array. In that we have performed the p plus I operation. So this I is nothing but the I value we have initialized inside the for, and I less than n and I a plus plus. So p plus I, which means nothing but I is nothing but an integer. So this integer value we are adding to this particular addresses, which particular pointer variable. In pointer we have the addresses. So to that address we are adding the integer. So what happens if you are adding that integer to that pointer variable? It is multiplied, the integer value is multiplied with the size of the data type. So in addition operation, see here, the address pointer plus number to be added into bytes of memory required by data type. See, address is considered P, we have the 100 value, and next plus number that we are adding here is 0, and a multiplication operation, and what we are multiplying it with, bytes of memory required. So if you are using integer data type, the size of the integer is 4. If you are using float, the size of int is 4. And if you are using char, the size of char is 1. So the bytes that is used to store that particular value that we are using, that we are used here for in multiplication. So 0 into integer data type we are using here. So 0 into 4 will be equals to 0. So that will be equals to 1000. And next 1000 plus 2. if it is 1000 plus 2, then to this 2, what we are doing, we are multiplying with the size of the data type, that is 1000 plus 100 plus 8 will be 108. For suppose we are using the char data type, and the address and the pointer variable we have, consider the address of that pointer variable is 100, and we are adding some 5 to this character pointer variable. So if you are adding 5 to this character pointer variable, what we are doing, 100 is the address of the pointer, and number to be added is, that is nothing but 5, and the bytes of memory required for the data type, the bytes of memory required for the char is 1. So into 1, that will be equals to 1005. So as we know, the size of the character is 1. So 1 byte is used to store that particular single character. So that is the reason why here we are multiplying that integer by using a 1. So it will point to the 105 address. So we'll go with an example operation for this addition, to perform this addition operation. So here the addition operation on pointer variable is calculated using the formula address at pointer variable plus number to be added into bytes of memory required for by the data type. And one of the example is hash include header file we are writing and the main function, and here we have declared an array. So array is, so some 10 values we have, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The index is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the name of the array is A, and in A we have the base address, consider it as 100 location, 104, 108, 112, 116, 120, 124, 128, 132 and 136. So why there is a difference between the 4 bytes? Because one integer is used to store, one integer is having the capacity of 4 bytes to store that particular value. So that is the reason why there is a difference between 2 addresses is 4 bytes. And in this A we have the 100, and this 100 will point to this array. It will point to the off 0 element. And next one more variable, that is pointer. Pointer variable we have declared, and also I variable also we have declared. So consider this address is some 200 and this address is some 300. And next to this we are assigning the address of A of 4. So A of 4 is this one, 4th index position. The value of A of 4 is this one, and we are using the address operator. So address operator is 116. So to this P, in the P value, 116 value will be stored. And next statement we have given as P, so which means we are changing the value of that A of 4. So star P is equals to -1. So in star P is nothing but star of P value is 116, that is equals to -1. So the -1 we are assigning in this particular address. So this 116 will be stored by using -1 after executing this particular statement. And the next P plus 3, see, to this pointer variable we are adding an integer. In the P what we have a value of 116 plus 3. So to these 3 we need to multiply with the size of the data type. Size of the data type is 4. So 116 plus 12. So it will reach to the 128. 116 plus 12, it will be the 128. So and before this, and we have a star over here. So star of 128 is equals to 0. So in this 128 address location, the value we are giving it as 0 by using this equals to operation. We are assigning the value. And then next we have star P minus 4. So the P value is 116. So 116 minus 4. So if you are subtracting, if you are adding or if you are subtracting an integer, we need to multiply with the size of the data type. So -4 into 4. That is equals to 116 minus 16. So here multiplication has the highest priority. So this operation will be performed first and the result will be subtracted to the address. So that the value of this will be is equals to 100. So to this 100, we are assigning the value as a -2. So in the 100 address location, what we are giving? We are giving the -2 value. So -2 value will be stored in this. So this is nothing but an example program how we are adding an integer and how we are subtracting an integer from a pointer variables. So this is a pointer variable 116. We are adding 3, and to the 116 to the same address we are subtracting the -4. If we add or subtract, we need to multiply with the size of the data type. And the next p is equals to a, and we are printing all the values that are present inside this array. All the changes, whatever the changes we have done. The p value is 116. So in order to get the values from the 0 index, we need to assign the p value as a. That is nothing but p is equals to, instead of 116, we'll get the 100 will be replaced instead of that 116, and p plus I. So p value is 100. 100 plus 0. To the 0 we are multiplying size of the data type will be equals to 100. Before we have a star. So star 100, that is nothing but -2. -2 will get printed. Next I value will get incremented. 100 plus 1 into 4, that is equals to 104. And before this we have a star, so 2 value will get printed, and so on till 10. So whatever the value, whatever the integer value you are adding or subtracting, we need to multiply with the size of the data type. And next is a program to pointer increment and decrement. So some operations that we have seen, that is adding an integer and subtracting an integer. So the previous program that we have seen for adding and subtracting an integer. Next is incrementing and decrementing a pointer variable. So incrementing and decrementing a pointer variable. So then nothing but we have pointer variable we are incrementing and pointer variable we are decrementing. Next here we have array, and array value is 1, 2, 3, 4, 5. And the next one, a pointer variable also we have. And the next a value we are assigning to this p. To this pointer variable we are assigning the address of a. And next is, so p plus plus. So we are incrementing that a p variable. So here, say consider a, and the elements here are 1, 2, 3, 4 and 5. Index values are 0, 1, 2, 3, 4. And we consider address are 100, 104, 108, 112 and 116. And in this a we have the 100, which means nothing but the base address, and this will point to this auxiliary elements. And next here what we have, one pointer variable, the p variable, and to this p we are assigning the address of a value. A value is nothing but the 100. So the 100 value will be assigned to that p. So that is the reason why, see, this name of the array contains the address. That is the reason why we are calling this array as the internal pointers. And next p plus plus. Here we have p plus plus. So which means p value is 100. So p plus plus means is equals to 100 plus plus. So that is p plus plus is nothing but that is almost equivalent to p is equals to p plus 1. We are adding 1 to the p, and the same value we are assigning to the p. So the p value here it is 100 plus 1. So just now we discussed if you are adding any integer or any constant to these addresses. So what we need to do, we need to multiply with the size of the data type. The size of the data type that we are using for int is 4. So 100 plus 4 will be is equals to 104. So now this pointer value is 104. So instead of this 100, the pointer value will have 104, because by using this p plus plus we are incrementing that pointer variable. So the p value is going to change. Now p is equals to 104. So now the p is pointing to this, pointer is pointing to this second element in the array. So that is the reason why if we print by using star p, we'll get the value that is present in 104 address, and by using this p we'll get the value, we'll get the address value. And the next is p minus minus. So if it is p minus minus, this is almost equivalent to p is equals to p minus 1. So that is equals to p value is 104 here. So 104 minus 1 into 4. So if you are adding or subtracting a constant from a pointer variable, we need to multiply with the size of the data type. So that will be is equals to 100. So now P is now P value is having as a 100. Now P is pointer is pointing to the first element. So that is the reason why if we print the star P, we'll get the value as 1, and if we print the P, we'll get the value as the address as 100. We are assuming the address as 100, but the actual address of the first element is this one. The second element is this one. In the initial case, we are assigning A to that P, and that we are incrementing. The P value we are incrementing, that is the reason why we are getting this address, second element address. And the next P value we are decrementing, so we are getting the first element address and also the value as 1. And the next is subtracting two pointer variables. So what will happen if we subtract two pointer variables? Two pointer variables having the two addresses, two different address locations. So here, see, consider we have A of 7 and the elements as 7. So consider my array as 1, 2, 3, 4, 5, 6 and 7, and the index values as, and in this A we have the 100. So this is 100, 104, 108, 112, 116, 120 and 124. And we have taken two pointer variables, that is P1 and also the P2. See, in P1 we are assigning the A value is 100. And in P2 we are assigning the P1 plus 3. P1 value is 100. 100 plus 3. So if you are multiplying, if you are adding any integer to the address, we need to multiply with the size of the value. So we need to be very careful about value and also the addresses. If we have any operations like P plus 3, P plus 1, P plus 2 or P plus plus, in that case we need to add the address. We need to add that constant to the address. If we are adding constant to the address, then we are multiplying with the size of the data type. So if you are doing any value operations like A of 0 plus 1 or A of 0 plus 10. So at that time A of 0 is nothing but 1. 1 plus 10 is equals to 11. So this is the direct operations that we did till now. So but this is the pointer operations, that is nothing but some values we are adding or subtracting to that addresses. Address is different, 100 is different, and this A of 0, 1 is different. The constants are same, 10, 3 or any other constant, any other values we can add. So 100 plus 3 into 4, that will be equals to 100 plus 12. 100 plus 12 will be equals to 112. So 112, this answer will be 112. That value we are assigning to the P2. And we are finding the differences. We are subtracting the two values, two addresses. So the first value we have P2 minus P1. So this is a P2 and this is a P1. So if we subtract this, so 2 and 1. So to this 12, we are dividing with the size of the data type. The size of the data type that we are using is int. So the size of the data type is 4. So 12 by 4 is equals to 3, which means the values that we can store in between 112 and 100 address locations is 3 values we can store in between these two addresses. So you can find here 1000, 100 and 112. So these are the values that we can store. 1, 2, 3 are the values that we can store in between these two addresses. So that is the result that we have got here. 3 is nothing but it is an indirect subtraction. So how many values we can store in between those addresses? So that was given by using this pointer subtraction. So next is the array of pointers. An array of pointers can be declared as integer data type and array and also a pointer. So we are creating a pointer to the elements. Which means we are creating an array and in that array we are storing all the addresses. Instead of values, we are storing the addresses. This is nothing but the array of pointers. So in that particular array, we are storing all the pointer values. And in the above statement declares an array of 10 pointers where each of the pointer points to an integer value. For example, here we are taking A is equals to 1, B is equals to 2, C equals to 3 and D is equals to 4. And then next we are taking one pointer array. It is a pointer array. So pointer to array and array of pointers is different. So in a pointer to array, we are having only a single pointer. And by using this single pointer, we are accessing all the array elements. And coming to the array of pointers, we have an array, and in that particular array, we can store only all the addresses, and that address can be accessible of all these integer values. And this is an array of pointers. So we have like these are nothing but this is nothing but the array, and in this array 0 1 2 3 4 5 we have declared the size as a 5. So in this what we have given address of A. So consider the A address is 100. So the 100 value is stored in P of 0. So this is P. So consider it is 1000, 104, 1004, 1008, 1012, 1016 are the memory addresses of each pointer variables. And next address of B that we are storing in P of 1. In P of 1 we are storing address of B. So consider that is some 200, and next is 300, next is 400, consider, next is 500, consider those address locations. And next we are printing that values that are present inside this array, inside this address. So now see percentile D, what value should be reflected here? Star P of I. So here P of I is nothing but 0. So P of 0 is this 100. The value of P of 0 is 100. In before this P of I we have a star, that is star will tell the value that is present in 100 location. So 100 location the value is present as 1. And next is I value will get incremented, I will be is equals to 1. And now next P of I is P of 1. Before this we have a star. So P of 1 value is 200. So 200, the value that is present in 200 address location is 2. And the value that is present in 300 address location is 3. The value that is present in 400 address location is 4. We do not give any value, so it contains some garbage values or 0 in this last. So the values that are displayed in this particular, and the values are displayed by using that particular addresses. Thank you.